Hello. In the past, I've featured a digital time-based corrector from a long-extinct manufacturer who has been absorbed by other manufacturers over the years. Digital Processing Systems, it was a DPS-375, and the very special thing about this digital time-based corrector is it will accept the dub inputs from a U-matic video recorder and allow you to output S-video or YUV for video capture. Amazing piece of kit. Is a very good time-based corrector in its own right, but this ability to do dub connections is priceless. And I have two of these actually in use in my studio, plus a third is a spare. And a spare is a good idea because you can't get any service information on these at all. The chances of ever seeing another one of these incredibly rare things is just about
Special
zero.
Delivery.
Ooh, I wonder what's in this. Okay, let's open this up and see what we have. And here we have another DPS-375. Some of these have SP in the name and some different coloured controls, but I don't know there's any difference between the ones without the SP and I think a black control there. Now, the thing that makes this so special is that you have dub in and out. Well, it's in that we really need, so we can get a dub cable. Well, actually that's a difficulty because they're really hard to get, but you get a dub cable from that to a U-matic player. You also need to connect the composite video, which they call PAL in, to the video out. If you don't connect that one, you don't get colour. And then you can use this to give you YUV out or S-video out for video capture. We've looked in these before, but we will look in this one again. For one thing, I want to see if both fans work, because I've had some where the fans don't work. But this unit, I have been warned, may be a little bit less than perfect. So, to make sure everything is as it should be, what I need to do is either give it a colour bars signal from one of my generators, or I think even possibly from its own internal generator, and look at the output from, I don't know which connectors. Certainly I would try composite, start with composite and then try the others. Look at those outputs when connected to a Vectorscope. I have a Vectorscope. That's the good news. Well, I have two. One which would be perfect but doesn't work, and one which does work but has SDI digital input only. So unfortunately, what I'm going to have to do to test this is put the output of this into some video recorder which can go from composite to SDI, or some other piece of equipment that can do that for me, and then connect that to the Vectorscope. Right, so let's first take the lid off this, power it up and see what it does. Actually, I'll take the lid off in a moment. I can see whether the fans are spinning, I think, from here. So I'll just power it up from here, and I've got it on a TV, so on composite video out, so we can just see if we can get the colour bars. Let's start by just powering up. They're quite noisy, the fans on these. On off switch. Sounds like both fans work. Good start. So we'll select test on this control. Let's see if we can see that. So it's presently in process. We'll go through bypass and to test. See if we get colour bars on the screen. Yes, they look absolutely fine to me, but of course I'm not a Vectorscope. And this is our input selector, and it's flashing because there's no input, and I will select this in due course to the different inputs we're looking at. So some of the other controls on here we can go through later. We've got digital noise reduction of both chroma and luma, which is really wonderful, and other adjustments such as the various levels, and you can shift timing of signals relative to each other. Right, so let's take a quick look inside, make sure everything looks happy inside, and then we'll start finding a way to connect all this up to a Vectorscope. Right, we've looked in these before. Big power supply there. A huge amount of circuitry, including tantalum capacitors, which I'm told may fail. And a chip there that I'm particularly proud of because I may have helped to make that chip in a former life. It's extremely clean, this one. Very little dust indeed. It looks like it may not have put in too many hours. There's two levels of PCBs here, so there's a big set of boards on the top and another set underneath. There are dip switches in here, and I think what they do, but it's not terribly obvious, is they can act as though it's a front panel. So you can take this front panel off and you can set those dip switches. And I don't quite know how it activates those as opposed to the front panel. Don't have the user manual, but I think for the most part you can ignore the dip switches. They're so inaccessible anyway. If people were supposed to fiddle with them a lot, they wouldn't have hidden them behind this. You have to undo these screws to take this off to get to them. Okay, so we're looking at tantalum capacitors variously around. I'm going to take a close look to see if anything looks like it's been repaired or anything looks like it needs replacing. One of the controls here is marked DOC sensitivity. What that's about is you can feed a copy of the RF signal from the video head, which is supplied on the back of some professional machines, into the back of an RF input on here, and it will detect when that RF level is so low due to a dropout on the tape that it needs to activate the dropout compensator that's built into this. So rather than relying on the analog dropout compensator that the video recorder will already have, you can use a digital dropout compensator from the memory of this timebase corrector. This board is dated 5093, so this board design dates from the end of 93, but a lot of the chips are dated 94, though the Plessy chip there is actually from 1988. I should say for a long time we've been trying to get hold of the NTSC equivalent to this, which is DPS-275, and I ordered one from USA. I was absolutely delighted it was on its way, and it got lost in shipment and was never found. So that was a catastrophe. Really wanted one of them so that I could offer the same level of pneumatic transfers potentially with NTSC as I presently can with PAL. I'm going to see if I can get access to the power supply and just see if there are any visibly distressed capacitors under that shield. Again, just taking a visual look, and I must say everything looks very clean and low mileage in the power supply. Looking in the power supply, there's actually a 115 and 230 volt selector right here. So it's a real pity that one from America didn't arrive, because it would have been very easy just to move that link to the 115 volt, from 115 to 230 volt, and I would have been ready to go with one that was easy to power in the UK. Such a shame that one got lost. Okay, I've set this up. I'll show you what I've got here and then see if anything works. I've not tried this yet. So we have at the bottom here, the timebase corrector, which is set. We're just going to be using its built-in color bars initially. Hooked up to this DVCPRO 50. It's a Panasonic AJD950. And presently that's also configured to do color bars, so we'll have to set that up to YUV input or YPBPR. So I've got those three connections, the Y, the PB and the PR connections from the output of the timebase corrector into this, and then SDI out, digital data stream out of this into the Vectorscope. So first thing, we'll switch this on and we'll see if we get on the monitor, which is disconnected by composite video, we should get, right, that's the color bars that are being generated internally here, and if we look at the Vectorscope we should get the color lands if I'm in the correct kind of color bars, because it's 75 or 100%. Right, we're set to 100%, so those dots are all landing in the squares, so that's all good. Right. We'll switch it off again for a minute because we don't need that for just a second. Let's get this out of generating its own internal colour bars by going to the menu, and then we scroll through here. I don't know if you can see all that. I think you can. And one of the options in here somewhere, int SG number 600, and with that I can change from CB, which is colour bars, to off, and then I press set and the colour bars should disappear. Now we select video to be this input here, the YPBPR. Switch on the timebase corrector. That's set to bars, and it's not working. That's a little disappointing. Okay, well, let's just go for composite video then. If that one doesn't work, and it's flashing, so it's not seeing an input. Well, maybe it also needs composite video for the reference. Let's just connect that up as well. Okay, I've connected composite as well. No, just nothing. Okay, I may have a button set wrong somewhere. I was on the black output here. But let's just go through. So I should be able to see. So now what we're seeing here is the test signal from here is being fed into here. Let's get the color bars up. So that's black, bars, no bars. I'll get that test signal, but it seems a bit unstable. But that one's there. That one's there. Black is just black. But no colour bars. But the colour bars are working on this. We saw it a moment ago on the TV. And why is that taking time to settle? You know what's going on here, don't you? This is a DVCPRO. It's not working properly because DVCPRO machines are so unreliable. So there's something wrong with the video on this. Oh dear. So I'm going to have to find another machine more reliable, like a Sony, to replace this DVCPRO heap of junk. Okay. Of course I could be blaming the messenger. It might be that the timebase corrector is not putting out a good valid colour bar signal. There's something wrong with the timing, and the DVCPRO deck is therefore not synchronizing to it. So I could be blaming the messenger. It might be that the problem lies here. It could be a good enough signal to display on a TV, but not actually valid. It's still a good test though to put a Sony digital Betacam here. However, the Sony digital Betacam I'm thinking of using may or may not have a composite video input. So we may only be able to try the YUV input, but let's hook that up and see if that gives us all the test signals. Okay, if I've done it correctly, we've got the same. So I've got both composite and YUV connecting the TBC to the digital Betacam recorder, and then that is connected via SDI to the Vectorscope, and composite video out to the monitor. Right, let's start with the DigiBeta. So that's set to, we'll start by, yes, have the colour bars from this on the Vectorscope. Okay, that's perfect. Right, now switch on the TBC. That's a strange waveform image. What's going on there? Looks like it's not got proper synchronization. Maybe we need a reference video connection. We do have the correct lands here for the test signal from the timebase corrector. So we need to sort out synchronization, and then we can also feed this with a color bar from a different generator to see if that looks good. Okay, I've moved the cable that went to composite video in on here over to ref in on this machine, which gives it sync pulses from here, and we're now good. So we've got a good display on here. Actually, I'll get you a little bit closer so you can see that, and we have good synchronized color bars. Well, hopefully you can sort of see that the colors are landing in the squares on these graphical markings. Right, we have one more piece of kit added to the mix. It's a digital time-based corrector, but in this case we're using it just as a color bar generator. I forget if it's 75 or 100%. I think it's 75. That's how much modulation there is in the chroma. So that is feeding a composite video out into the time-based corrector, the one we're trying to test. And then that's going to the digibeta to give us an SDI out, which is being fed to the Vectorscope. And we can also see it on the screen when I push it out of the way. So let's start switching this gear on. Right, so test select on this will give me the color bars. I'll push it out of the way so you can see the screen now. Right, let's switch on the time-based corrector we're testing and make sure this is in what it calls PAL mode here. So we're not using one of the YC inputs, which is pneumatic. We're not using what it describes as beta, which I think is YUV. M2, I'm not sure what the difference on Betacam and M2. But anyway, we're on PAL, which it means composite video in. We'll need to make sure that all these settings are 0, Y level, black level, chroma phase, and the timings. We want everything to 0. And what's this one? More phases. The encoder here doesn't seem to be working particularly well. Jumping around a bit. Right, I've got them all set to 0. Good. So whatever goes in should come out. Switch on the digibeta, and that's routing it through to the monitor as well. That's all looking good. I can press this test select button on here and we'll see that that goes red. No. So what have I done wrong? We're still in test here, not process. Select process. Try again. Right. So now I'm feeding a composite video in and I'm getting a disgusting mess out because I've got this set. I had this set to NTSC instead of PAL. Try again. Okay. And then you can select this test button and go through red and what have you. So right, okay. So now this is the key point. We'll switch this on and see what the performance of the color bars from here through this whole system is. And it's composite video, so the dots look a little woolly compared to how they should, but you know, good enough. And it's 100%, isn't it? Because when I set to 75 it's way off, so it is 100% color bars. And looking closely at them, there is a tiny error in some of them, but it's pretty small. Right, I can do chroma phase on here, and I think we can tighten up some of those very slightly. I don't know if you can see that, but it looks just a tiny bit better with chroma phase adjustment. Chroma level, that moves them in and out. So the chroma level at 0 is that, and if I take it up to +3, +8 in fact, they're all more or less landing in the squares now. So the chroma level might have been just a tad low. I don't think there's any more to do. I think we are there. And of course we're depending on the quality of the color bars signal coming from here. So those small adjustments could actually be, as much as anything else, a result of inaccuracies within the time-based corrector that we're feeding it from. But I'm not seeing anything significantly wrong with that. The Vectorscope here is showing a waveform display for this test signal that's generated inside the digital Betacam. Switching that off, this is the waveform display for the test signal being generated in the DPS-375, and switching that test signal off, so going to process here, that's the waveform display of the test signal which is coming from this time-based corrector. Now that's a little bit rough because of course it's composite video. Let's going back to the internal test signal. Are the heights correct there? Is there a problem with that waveform, or is it just a different type of waveform? Well, I think the best way to be sure if that signal is right is to set the Vectorscope up on my other system downstairs, which has a different digital Betacam machine and a different DPS-375. The chances of them both having the same fault are negligible, so let's see if we get a similar signal downstairs on another kit. So down in my studio I have the same setup. I've got the DPS-375SP feeding the digital time-based corrector, and now we're going up to our waveform monitor mode here. Let's switch the lights off, and you can see we get the same waveform when this DPS-375 is in its test mode, but it is different from the digital Betacam's test mode, which has different step heights. So that's the DigiBeta one, and that's the DPS-375 one. So I'm quite pleased with that. I think we've quite thoroughly tested this DPS-375, at least for composite video operation. It's a little bit harder to test for dub because I need to sort out some signals for it, but it looks, for the time being, as though this machine is in good working order. A big problem, as I mentioned earlier, is getting dub cables, and the reason that's a problem is because you can't get hold of the plugs that you can make up the dub cables with. There was a company that was offering to make up dub cables, or you can do it yourself, although it's not much fun, but getting those plugs is a major problem. So if anybody has any dub cables lying around that they would like to send in my direction, please do, because I have machines I could connect this up to. Right, I hope you've enjoyed this little experiment. I will do plenty more content, mainly on audio and video technology. Do come by and see me doing that in the future. Bye for now.